Hello everybody again. This is Mr. Zondo, and today we're going to do lesson 9.2. So lesson 9.2 is going to be about solving quadratic equations by factoring. So we're going to look at how factoring is going to solve the quadratic equations. We got two vocabs for today. The two vocabs for today are a standard form of a quadratic equation, which most of us probably already know, but also we're going to learn about the zero product property, which is going to be really important. So by the end of the lesson, what we want to do is to be able to find the solution of the quadratic equation by factoring. The first thing we want to do is look at our model and discuss section. So if we check it out, we kind of want to get a scope of what's going on. We see we've got over here a nice little like tile mosaic someone's making of a farmhouse. So it says the artist has started the mosaic tile design on a wall. She needs to cover the entire wall. So if you want to take some time to read through the questions and try and do it on your own, pause the video now and check it out. But for part A, it says write expressions to represent the length of the wall and the width of the wall. So we're going to say that the length of the wall is this whole section, because we have to go all the way out to the end of the wall, which means we have to have this 6 and this x. So the length of the wall is going to be 6 plus x. I'm going to put that in parentheses. The width of the wall has to be our up and down length. So our width's going to be 4, because we got 4 right there. And then this piece is x. So our width of the wall is 4 plus x. Now at this point, you might be seeing, it looks like an area, so it looks like we might have to do something with the area model from last section. We'll find out. We'll find out. So it says, what expression represents the area of the entire wall? Well, to get the area of the entire wall, area of a rectangle is length times width. So to get the area of the entire wall, yeah, it looks like we're going to use our area model, because we're going to have to do our length, which is 6 plus x, times the width, which is 4 plus x. So that'll be the area of the entire wall. For part C, it asks, how can we determine the part of the wall that the artist has not yet covered? So we want to find out all of this area. Now it's true, we could use our area model and multiply x times 4 and 6 times x and then x times x. So we could do that. That would work out. But if we wanted to, we could also do it with a subtraction. We could say that the area left over, and this is going to be an important thing in geometry, but the area left over is the area of the big piece, so in this case the whole wall, minus the area of the small piece. So in this case, that would be just the mosaic that's been done. And if we just subtract those two areas, we should get all the leftover area. So if we look the area of the big piece, because we want the area of the entire wall, that was this expression here. So that's 6 plus x times 4 plus x minus the area of the small. Well, the area that's already done is 6 times 4. 6 times 4 is 24. So minus 24. So we can just use this as our model. It doesn't ask us to solve, so we're not trying to solve anything. So if we look back up here, it's a model and discuss. So we've made the model. So the model is going to be 6 plus x times 4 plus x minus 24. And that's a good model, because then once we figure out what x is, we can just plug that in and we can use that whenever we want. Even if she adds more to the mosaic, this equation is still going to be mostly true. We might have to add to the 6 and the 4, but our format, our structure is going to be the same. So for example 1, we talk about the zero product property. Like I said, zero product property is pretty important. If we think about multiplying by 0, if we want to get an answer of 0, there's only one way to do it. So if we get a result of 0, then what we had to do is we had to multiply by 0. That's the only way to multiply to 0, is if one of the terms is 0. Because if you pick two other numbers, if none of them are 0, you're never going to multiply to 0. So that's actually really powerful. It doesn't seem like it's that powerful, because how often do you want to get to 0? But we do a lot, because if we can get to 0, then we can do a couple other math tricks. So we're going to find out how we can use our zero product property with factoring to solve our quadratic equations. So at first, we've got a nice quadratic equation. It's in factored form, so it looks like it's well set up to start the zero product property. And to do the zero product property, what we say is, well, since we got 0 as a solution, that means one of these has to be 0. So either x minus 9, oops, not x equals 9 yet, x minus 9 equals 0, or 5x plus 2 equals 0. It's one of the two. So we're going to add 9 to both sides here, so solving like we did all the way back in September to get x equals 9. Here we'll subtract 2 from both sides, so 5x equals 2, divide both sides by 5, so we get x equals 2/5, or if you did in your calculator, 0.4. Now the thing with quadratics is we're allowed to get two answers. So remember when we solved them graphically, we could get two answers, we could get one answer, we could get no answers. We got two answers, we got two solutions, because it turns out if I put 9 into the equation, I'll get 0. If I put 0.4 or 2/5 into the equation, this isn't going to be 0, but this is something times 0, which gives me 0. So down here we got the triads. Feel free to try them out. But we want to solve them using the zero product property. So over here, 2x minus 1 equals 0. So x equals 1/2, or 0.5 if you did it with the decimals. Over here, well, that one looks a little bit more friendly. We get x equals -3. So it's okay to get negatives. Over here, same deal. We just set them both equal to 0. So you always want to set the parentheses equal to 0 when you do the zero product property. So -3. So 2x equals -3. Divide everything by 2. X equals negative, we'll do the decimal over here since we did all the fractions over there. So -1.5. Over here we add 1. So 3x equals 1. Divide both sides by 3. I'm not going to turn that into 0.3 repeating. I think 1/3 is a much better option than 0.3 repeating. So we get two answers for each of those, and that's it. That's all we have to do for that part. For example 2, we're going to go and put everything together. So if you remember standard form for a quadratic equation, we had our standard form last time for our quadratic functions, which was ax squared plus bx plus c. The only difference here is our standard form of a quadratic equation has equals 0. So that's always going to be your first step, is you always want to make your quadratic equation equal to 0. So that's going to be kind of our first guiding first step. Our last step is always going to be to try and do the zero product property. So from what we've done before, we've done all the middle parts. Now we just added a beginning part, we added an end part. So we're going to use factoring to solve this. So our first thing we want to do is beginning part, is it equal to 0? No. So that means we have to make it equal to 0. So I'm going to do the first part, which is to make it equal to 0. So I need to add 20 to both sides. Now x squared doesn't combine with 20. Those are not like terms. Neither are 9x and 20. So we just have x squared plus 9x plus 20 equals 0. Now we factor. Again, you can factor however you want. I'm going to go through a couple different methods for factoring. But the first one I'm going to do is my favorite one. I like to factor with the boxes. So I'm going to make the boxes. We got x squared. We got 20. We got 9x. We got to find out what multiplies to x squared times 20 is 20x squared. So it multiplies to 20, adds up to 9. So I'm thinking 4 and 5. 4 plus 5 is 9, so that's right. So I got 4x and 5x. All right, let's do some GCFs. Along the bottom, we got x. This one we got 5. Then we do some division. X squared divided by x is x. And then 20 divided by 5 is 4. So this one broke down into x plus 5, x plus 4. We still have equals 0. So that's kind of the new part for today, is we got the equal 0 part. From here, it's zero product property time. So we set each of these parentheses equal to 0. Subtract 5 from both sides. X equals -5. X plus 4 equals 0. Subtract 4 from both sides. X equals -4. So we get our two values for x. All right. So that brings us to the try it for the second dot. So for example 2, you can try them out if you want. Like I said, there's a couple different ways to factor. Some people have gotten to the point where you can just factor just by looking at it. You could say, oh, okay, I got 64 there. It looks like 8 times 8. 8 plus 8 is 16. Since there's no number in front of x, we know that's going to be x plus 8. X plus 8. We can factor that by inspection. So that's one other way that you can factor. If we use the zero product property, we get -8. And since this is the same as that, I don't have to do it twice. I can just do it once, since we know we're going to get the same answer. Like we said with the quadratics, sometimes you get 2 answers, sometimes you get 1 answer, sometimes you get no answers. This time we only got 1 answer. For the second one, we can see this one does not equal 0 at the beginning, so I can't jump right into factoring. I got to make sure I equal 0. So I have to subtract 64 on both sides. So x squared minus 12x minus 64 equals 0. Now I'm going to do this one a little bit different because, again, there's a lot of different ways to factor. So I'm going to say, well, I got this 12 here. What if I split it up? X squared minus 4x plus -8x minus 64. All right, well, greatest common factor here is x. So I can factor this by grouping. Greatest common factor here is actually -8. A little bit weird, but that's okay. We got that okay? Yeah. So let's see, did we end up with the same things? Oop, that should be a plus. We did not. Uh-oh, looks like we're in trouble. So what we gotta do, gotta pick different things. 8 and 4 didn't work out. So let's see, what else could we pick? Well, the part where we messed up is we saw this was negative, which means they have to be opposite signs. So let's try x squared plus 4. Then I need a -16x. All right, this will still give me a greatest common factor of x. Here, though, we need x minus 16. And then 64 divided by 16 is 4. So that works out. These two match, so we know we did factor by grouping correctly. So we bring that out as the new GCF, and the leftover pieces are x and minus 16. So we're going to extend the page, just so I got a little bit more space to do the zero product property. Equals 0, equals 0, equals 0. X plus 4 equals 0. Subtract 4 from both sides. X equals -4. X minus 16 equals 0. Add 16 to both sides. X equals 16. So that's how we can do it. So we can do those all by factoring because that's the name of the game. So I've shown you how to do it by factoring. So we're going to look at it in a word problem. So example 3 has a word problem. We've got the museum vault there. And we're going to try and find the width of the outer steel wall. So we're going to try and find x. That's what it's asking to find, is the width of the outer steel wall. So we're going to set it up. It looks like it's an area problem. So if we look at the length, we've got 40, but we also have an x and another x. So the area is going to be 40 plus 2x times, well, if we go this way, we got 20, but we have an x on this side and an x on this side. So 20 plus 2x. Now, if we look in the problem, they give us the total area. They tell us that the area of the vault ceiling and the steel wall is 1664 feet squared. So it would be the entire area. So that means I actually know 1664 equals 40 plus 2x, 20 plus 2x. Well, we want to solve it. So if we want to solve it, first step, make it equal to 0. So subtract 1664 from both sides. Now again, that doesn't really combine with anything because all those numbers are stuck in the parentheses. So we just end up with 0 equals 40 plus 2x times 20 plus 2x minus 1664. So at this point, we're in some trouble. If this was an honors class, you'd keep doing it with the algebra. You'd have to multiply the 40 plus 2x times the 22x using either the area model or FOIL, combine like terms, combine more like terms, then factor it, then zero product property, and then plug it back in to get the final answer. But we're not going to do that. So I've already shown you how to factor it, so I do want to show you a shortcut. So if you want to use your graphing calculator, we can actually plug the equation right into the graphing calculator. Notice I didn't put in the equals 0. You don't need to put in the equals 0 because 0 is going to be the x-axis. So we want to find all the solutions to this equation. Well, it looks like there's one right there at 6, 0. But remember, these could have two solutions. So we got to make sure we find the other one. So let's see. I zoomed out a little bit. There it is. Negative 36 and 6 are my answers. So we got x equals 6, x equals negative 36. Now we're not done because it doesn't ask what is x. It asks what's the width of the outer steel wall. Well, I guess that does ask for x then because x is the width of the outer steel wall. So we got two options. Could be both. But would it really make sense that negative 36 would be a width? Not really, because we're looking for a positive integer or some positive number that would be the actual width of the wall. You can't have negative 36 feet. We also know it's going to be in feet, because if we look at our units, our area was feet squared, so our length and our width are going to be measured in feet. So that's a way to shortcut it. So you can use Desmos to solve these ones. That's how to use Desmos to solve it. So if you come down to the other example, we'll try it down here. This one's a little bit trickier. That is that with the setup, they switch things up a little bit. So they tell you that the picture inside the frame is 375. So that means that only this piece is 375. So they don't want the whole thing. So we don't want to do 30 plus 2x. We actually have to say, the whole thing is 30, and I need to just get it down to here. So I actually need to subtract 2x from these ones. I'll show you 20 is at the bottom there. We'll write that up here. That didn't show up well with the face cam. So our equation is going to be 375 equals 30 minus 2x times 20 minus 2x. First step, subtract so that we get 0 on both sides. (20 minus 2x minus 375). And I'm just going to go and do what I did last time and just plug that right into Desmos. We don't need .1 anymore. We'll check out .2. And if we look, we see we got two answers, 2.5 and 22.5. All right, so we got to decide which one makes more sense as x. Well, I don't think 22.5 makes much sense because over here we were subtracting. If we did 20 minus 2 times 22.5, we'd get a negative number for a side. So I don't think we want that. I think we're going to stick with 2.5 centimeters. That would make a little bit more sense as the width of the frame. All right. For example 4, we're going to go backwards. So we're given the equation, we want to graph it. Now, obviously, if you want, you can just use Desmos to graph it. If you wanted to factor this one, it would end up being f of x equals x minus 4, x plus 2. If we do the zero product property, we get x equals 4 and x equals negative 2. So again, we set those equal to 0. And that's actually going to be the x-intercepts. So 1, 2, 3, 4. Negative 1, negative 2. And we know because parabolas are symmetric, the axis of symmetry has to be right in the middle. So that means it has to be right at 1. So somewhere there's going to be a vertex that's at x equals 1, where we can just plot the vertex point and then we'll get the whole parabola. So what we're going to do is plug 1 into the equation. 1 squared minus 2 times 1 minus 8. Again, I picked 1 because it was exactly in the middle of those two purple dots. So 1 minus 2 minus 8. So that's negative 1, negative 9. That's all the way down here. But then we can just draw our nice little parabola. And that's it. We've got our graph. That's all we have to do. So it's not too bad. We can also check, is the y-intercept 8? Yeah, if we wanted to, we could have used that. The graph wouldn't have looked as nice, but we could also do that because all you need is 3 points. All right, for the try it, same deal. We got to factor this one. All right, so with the try it, we've got this quadratic equation with the 2 out front. It's a little bit trickier. So I think I'm going to run through the whole factoring process for this one. So we'll just do it real quick. We'll make the boxes. And again, you can factor however you want. We get 2x squared minus 3. So we get negative 6x. We get plus 5x. So we need to multiply to negative 6 and add up to 5. So that's going to be 6x minus x. So what we want to do is subtract x. We got 6x there. We can do our GCFs. So 2x squared and x have a GCF of x. This is a GCF of 3. 2x squared divided by x is 2x. Negative 3 divided by 3 is negative 1. So we get f of x is x plus 3, 2x minus 1. So if we use the zero product property, here we get x equals negative 3. So negative 1, 2, 3. Here we get x equals, well, we have to add 1, so that's going to be 1 divided by 2. X is equal to 1/2. So we can kind of estimate that right there. And that gives us axis of symmetry that's not really that friendly. So our axis of symmetry is going to be negative 3 plus minus 0.5 is negative 3.5, so 1.75, so it's going to be 1.25 away. So that's actually going to be like, well, that's not really that. The axis of symmetry is going to be about there. So since that's a little bit annoying to work with, it might be easier if we just plop it right into Desmos, just to double check to see where the vertex is. And we can see I did that. Vertex is down here at negative 1.5, so that's good. We knew where that was. It's negative 6.125. So we're going to have to put a point at negative 6.125. So 1, 2, 3, 4, 5, 6, and a little bit. So that's 6, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, so we'll go right there. So when we draw a parabola, the more helpful point on this one is actually going to be the negative 3, since we know that's where the y-intercept is. 1, 2, 3. So we know we want our parabola to kind of go through all these points. It's not a very good parabola, but we'll pretend it's a little bit better. Desmos did a much better job of making the parabola. But that's how we can use factoring to get some of the points that we need in order to graph our parabola. If I wanted to get this point exactly, I'd have to plug negative 1.25 into the equation, which I would probably be using a calculator for anyway. So at that point, you may as well just go to Desmos. For example 5, now we're going to get the equation from the graph. So we have to remember our factored form from last time is y equals ax minus p x minus q. And the nice thing is over here, we've got p. Over here, we've got q. So y equals x minus -5 x minus 1. So y equals x plus 5 x minus 1. So our goal, just like we've done before, is we want to try and get a by itself. We want to figure out what a is. So to do that, we need to plug in the other point we have. So this is x, and this is y. So we get -9 equals a, -2 plus 5, -2 minus 1. All right. So that looks like that might work out. So -2 plus 5 is 3. -2 minus 1 is -3. A is still out front. That's a -9. So we get -9 equals -9a. All right. To solve for a, we just divide both sides by -9. So we get 1 equals a. So what we have to do is take this and plug it back in the last purple step before we plugged in for x and y. So our final answer is going to be y, or f of x, equals 1 x plus 5 x minus 1. Now, that's our final results, so we're all set. Now, if we didn't want to go through all of this, there is a little trick. So if we go 1 to the right of our vertex, we find that slope. That slope should always match up with what that number is. So if you're given a graph, you don't have to go through all the algebra if you don't want to. You can kind of shortcut and use the graph to help you out. So we're going to try that for example 5 to try it. Factored form of the function. Well, we got these two pieces. We know y is equal to a x minus p x minus q. P is at 3, 0, so p is 3. Q is at 9, 0, so x minus 9. Those in coordinate pairs. And to get a, all we have to do is go to the vertex, get to 1 over in the x, and find out what the slope is. Up 1 over 1. So a is 1. We know what y is. And that's it. We did it in one step. We just kind of plugged in everything that we knew. And that was it. That's all we had to do. So that's the end of this one. In general, we talked about the zero product property. That was where we said, hey, if your answer was 0, then you had to multiply by one thing that was 0. Could be both things are 0, but at least one of the things you had to multiply by was 0, because that's the only way to multiply by 0. We saw how to use that using our algebra. First step, we always want to make sure that we equal 0 on one side, and then we can factor and we can get our results. Or once we get it to here, we can use Desmos to find the x-intercepts of the equation. For the graph, we saw, hey, these are the x-intercepts, these are the important pieces, and those correspond to the zeros of the function. So the graph helps us to find that out. All right, that's everything with this one. Again, if you have any questions, feel free to email me or Mr. Dingman or whoever else you want to email. We're looking forward to it. Have a good rest of the day.